going to fit in a panel session with our morning speakers this morning. So just to remind you, we've got Dr. Sean Murphy, who is our hydrologist talking about soil moisture. We've got Pippa Jones, who talked about our Nuffield Scholarship around carbon, which was quite intriguing. And Professor Sam Clark, who talked about the methane beef efficiency research. I know we did have some people in the audience that had questions that didn't get asked, so we might go to them first, and then I've got some prepared questions to ask if we have some time. And the first one's going to be Mr. Wayne Chaffee just there. I'll let him go.
My questions to Sean. Sean, thank you. Great presentation, as were all three. Thank you. You talked about that ratio of 1 to the 1.6 in terms of evaporation, and so from your research, what are some of the best strategies that people can use on their farms to try and minimise that moisture loss?
Evaporation is a constant force. It's always there. During the warm season, the force is greater. During the cool season, the force is less. So those numbers I said, that ratio 1.6 to 1, that's for the coming 3 months, May, June and July. If you look at it over the whole year, it's about 3 to 1. So around 2,100 millimetres of evaporation force versus our 650 mils of rainfall. Which one do you think wins the battle? It's pretty stark. This part of the world, July is usually the only month of the year where rainfall can reliably, in inverted parentheses, exceed evaporation. Every other month of the year, evaporation is the dominant force. How do we manage that? The most simple way is ground cover. So research I did a number of years ago now, wherever we had, I think it was around 3,000 kilograms of litter, pasture litter on the ground, we had a suppression of evaporation rate. So what that means is that for the rain you receive, your pasture has a longer period of time to access that moisture and be productive. If you lose it as fast as you get it, then the pasture doesn't have the opportunity to utilise that moisture. So ground cover, 101, that is the primary way.
Yes, my question's for you, Sam. Thanks for your presentation. You were kind of put a little caveat at the beginning of your talk, talking about the methane emissions from cattle basically being part of a larger cycle, which I personally agree with, and I think there's people a lot more intelligent than I am in this space who also think that the accounting of methane is quite a poorly understood, and it's been motivated from an environmental point of view and in many ways by activists more so than the science. If it is ultimately shown that the emissions of methane from cattle, especially in a pasture-based system, effectively are a closed cycle that we're not adding to nor detracting from greenhouse gas emissions, and we lose the motivation in terms of methane emissions, are you finding any details from your analysis, the data, to give another form of motivation for us pursuing methane? So are you finding that reducing methane emissions is actually increasing performance in other areas?
So that's a really good question. So methane research didn't begin when people started to link methane to climate. The foundation of methane research actually comes from animal energetics, so understanding how feed is digested in the rumen. For a long time, that work was to understand, well, if we have this digestion, we create energy in our volatile fatty acids that the body can absorb. We also create this gas that has to be released from the rumen at some stage. That gas is anywhere between 5 to 10% of the energy that an animal eats. So the motivation behind methane research for animal science has always been around how can we capture this lost energy. Now, in the early 80s, a lot of work around the role of methane in the atmosphere occurred, and that's really when this climate discussion happened. So from me, for my research, I really think of it as an opportunity to think about, can we make more efficient beef gas, to try and think, can we see a reduction in this loss of energy? So it's a little too early to see if those low methane emitting lines that we do see in our projects are also more efficient, but that's really one of the goals that drives us, is to see, are these animals that are producing less methane than average giving us some extra productivity gains? Are they more efficient for feed? Generally, yes, but we still need more and more data to confirm that.
My question is for Sam too. And it's probably much along the same lines as the last question, but a little bit different. We grow oats to feed our cows on through the winter. Do you measure what carbon oats take out of the crop, or how, whatever they sequester, and then against what the cow eats of the oats against the methane emission? Is there any correlation there? And is there any offset?
So maybe I'll put it in a different way. So if we think of the question as being, what is the role of the type of pasture? If it grows faster, does that mean that you either sequester more carbon either in the soil or the plant or in the animal, or what's that role in the system? So in terms of our research, we've been looking at individual animal variation. So not so much what's the difference between pasture X, pasture Y, and its sequestration potential. So I just put that caveat at the start. What we do find across the multiple sites, across the 2.5 years that we've been recording these large groups of animals, we find if it is a higher performance pasture, then there is less methane produced by the groups of animals on average. Now that makes sense from a nutritional point of view, because microbes in the gut can break down that material quicker, and that energy is available to the animal to grow faster, and in essence they reduce methane for that individual animal. Now in terms of sequestration, I'm not sure. I'm not sure if any of the other speakers can add some extra information about what's happening, especially in that root zone, for if you have those different species.
I think I can add a little bit to your question in terms of an answer. So one of the other projects run at the TAI research station, and Sarah Baker's sitting up the back there, halfway up the rows. A question that was being asked was, well, is there a difference in that carbon dynamic, if you like, between straight oats and some of the multi-species forage mixes that are being promoted and used actively lately? Some data out of the last couple of years showed that the straight oat, well fertilised, well resourced, resulted in greater carbon and nitrogen in the profile at the end of the season than did the mixed forage. Do I have the reason why? Not sure I do, but those are the data. But essentially I think it's the oat being fertilised, it has the opportunity to both grow material, which means maybe there's more root material left behind in the profile, and led to that higher organic matter in the topsoil at the end of the season. So very complicated stuff. There is no simple rules of thumb, I think, that we can rely upon yet, but I respect your question. Yeah.
Thank you. Sorry, can I add to that? First of all, there's a really great resource called the Local Land Services YouTube channel, and the link is in the booklet. In November last year, we had a event in Tamworth on is tracking carbon good for business, and one of those presentations was by Dr. Susan Orgel, who's a soil scientist and nationally and internationally respected. So she, if you've got time, go to that YouTube channel, look at her presentation in particular. It probably more addresses the soil carbon side of things, but it's a really, really good presentation, goes for about half an hour, that might help make a few of those complexities clearer. And sort of backing up probably the earlier question as well, internationally, biogenic carbon, which is the carbon cycle that Sam talked about in his presentation, that isn't how carbon is accounted for internationally at the moment. There's a lot of research and there's a lot of pressure and pushback on changing that to make that happen, but that isn't the case internationally. So I think regardless of whether it is or isn't, at the end of the day, at the moment, the international standards for carbon accounting don't account for that. Is that right?
Just curious to know what the actual cost is of having an initial carbon account for your farm. Is it cost per hectare, or is there a flagfall, or how does it work?
So my answer would be to do it to start with, the first cost is your time. Yes, you can pay a consultant to look at all of your data and pull it together, but there are a lot of free online calculators, including this Agricultural Innovation Australia, so AIA. It's got a carbon calculator that was funded by all of the RDCs Australia-wide. It is one of several that you can use free of charge to plug your data in to see what your Scope 1 emissions look like, or your on-farm emissions, and what your Scope 2, which is your electricity emissions essentially. Beyond that, there probably is cost involved if you're wanting to do it outside just doing it yourself. It is the simple question.
I'm sort of thinking more of your actual soil carbon content, like taking core samples. Is it?
Well, we've got an answer up the back here. We'll draw from the audience for an answer as well.
For baselining purposes, if you actually baseline the soil test to do a carbon project, that actually occurs after you've commenced the soil carbon project. So to do the registration, to do the baseline, you have to commence the registration process with the government, and it's roughly around $20 to $30 a hectare. So it's extensive, and part of that is because, as Pippa outlined, the methodology is very rigorous and very, very high integrity. So that is outsourced. If you're working with a soil carbon developer like us, we don't do that. We have to get someone else to do that. We organise it, but it's about $20 to $30 a hectare, and that's why soil carbon projects are really best suited to properties with scale at this stage.
And to add on to that, it does depend on the service provider you go with. Some of those absorb those into the costs to set it up, but then the slice of the pie they take at the end is probably slightly bigger. Others will charge you that upfront cost, and the slice of the pie at the end is smaller for them. So that is very much a per business decision based on a whole lot of things that but the advice is always surround yourself with advice before going down any roads, just to make sure you're making the right decisions for your own business.
Just in the role of bypass proteins and things like that, we sort of talked a little bit about the mention with rumen modification. Have you had any experience with what happens to the whole methane or whole digestion process with these high protein bypasses at all?
The simple answer is not really. It's kind of like blasphemy if a geneticist talks about nutrition advice. So the simple answer though is everything that makes a feed more efficient essentially makes the system in the rumen more efficient too. So if a taking from some work from Roger Hegarty when he was at UNE and at the department. He found that if you have feeds that make the feed type go through the rumen quicker, there is a shorter digestion period, which also means there's less methane produced from that feed, because that methane is produced in the rumen. If it goes past the rumen quickly, then it doesn't have that opportunity for that initial fermentation, which means less methane's produced. There's a little bit more methane produced in hindgut fermentation for those feeds, because there's a little bit more available for the microbes in the hindgut, but generally they do influence that flow through the rumen. That'd be my broad answer in a sense. But of course, I'm a geneticist, not a nutritionist. So it's got a good caveat on it.
Hi, thanks all for your presentations. My question is directed to Sean. Sean, can you give us a bit more detail rather than flip a coin for the next 3 months particularly? Are we likely to see the pattern that's in the south come to the north?
Yeah, so first of all, that flip a coin, that's just the pure probability. So the probability is 50% whether we'll exceed median rainfall over the next 3 months. That's why I said flip a coin, 50-50. So the probability is 50%, same as a coin toss. Looking at that drought forecast map, you remember it was on the right-hand side, the projection for the end of July. It would appear that that progression was moving up from the south. At least the image gave you that. So I guess that falls back to the climatic drivers and what are they and which direction the moisture-bearing systems are coming from. So at these last few months, everything's been coming from that way, from the coast, and we haven't been getting those cold fronts moving up from the southwest. And that's why the poor old southerners are just copping it, because the high pressure ridges have been in the wrong location to allow those cold fronts to transfer up. So I guess what to look for is when the placement of those high pressure ridges starts to move a bit further north, which allows the moisture bearing cold fronts to come up from the southwest. If this present scenario maintains, then yes, it's probably on the bottom side of 50%. Understand what I'm saying about the weather maps there? Yeah. So at the end of 2019, I gave presentations and I referred to the percentile values of rainfall that we had here, and they were off the bottom of the chart. You know, they were in the driest ever bucket. Well, South Australia, I think Western Victoria, that part of the world is presently experiencing some of their driest on record rainfall tallies. So they're sort of a bit like we were 5 years ago. So watch the weather patterns, which way they start shifting.
All right, if we don't have any more from the audience, please join me in thanking our panellists for their time this morning.